Hello everyone, here is today's question. Suppose x, y, z are real numbers such that x over yz plus 4y over zx plus 9z over xy equals 24. We are asked to find the maximum and minimum values of the following expression, that is 1 over x plus 1 over 2y plus 1 over 3z. So we start with the condition x over yz plus 4y over zx plus 9z over xy equals to 24, which is not of very good form. We should multiply each of the term by xyz. So by doing this, we will have x squared plus 4y squared plus 9z squared equals to 24xyz. We may let a equals to x, b equals to 2y, and c equals to 3z. So this transform our question as the condition a squared plus b squared plus c squared equals, note that 24xyz become 4abc. The expression 1 over x become 1 over a, 1 over 2y become 1 over b, and 1 over 3z become 1 over c. We want to find what is the maximum and what is the minimum. Note that in this case, x, y, z are real numbers which can be positive or negative, but definitely x, y, z cannot be 0, and meaning that none of the a, b, c is 0. By AMGM inequality, a squared plus b squared greater than or equals to 2ab, b squared plus c squared greater than or equals to 2bc, c squared plus a squared greater than or equals to 2ca. When you take the sum and divide by 2, we have a squared plus b squared plus c squared greater than or equals to ab plus bc plus ca. And we know that the sum of a squared, b squared, c squared equals to 4abc. And since 4abc equals to the sum of square, so abc must be positive. And therefore, we can divide both sides by abc. We have 4 is greater than or equals to 1 over a plus 1 over b plus 1 over c, which means that we get the upper bound of the sum of the reciprocals. We need to check when the equality holds. Equality holds if and only if a equals to b equals to c, which means that in this case it is 4 over 3. Therefore, the maximum for this expression equals 4. This is not that difficult. More interesting part will be the technique to get the minimum value. After some effort, we are able to get the minimum value. Consider the square of sum of ABC. Since ABC are real numbers, so the sum also a real number, and the square will be greater than or equals to 0. So we expand this, and we have a squared plus b squared plus c squared plus double of AB, BC, and CA. This is greater than or equals to 0. A squared plus b squared plus c squared equals to 4abc. Again, ABC is positive. We can divide everything by ABC, and we left with, we should divide everything by 2 of ABC. So this is 2 plus 1 over A plus 1 over B plus 1 over C greater than or equals 0. This means that 1 over A, 1 over B, 1 over C is greater than or equals to negative 2. Now, equality holds if and only if a plus b plus c equals 0. And there are many cases that a plus b plus c equals to 0 and also satisfy a squared plus b squared plus c squared equals to 4abc. So example, abc equals 3 over 2, negative 3 over 4, negative 3 over 4. Or maybe 2, negative 1 plus square root 5, negative 1 minus square root 5. And a lot more. And each of these will give 1 over a plus 1 over b plus 1 over c equals negative 2. So this means that the minimum of 1 over a plus 1 over b plus 1 over c equals negative 2. In conclusion, this expression lies in between negative 2 and 4. where -2 and 4 both achievable, meaning that the minimum value is -2 and the maximum value is 4. That's all for today's lesson. I'll see you again next time. Bye bye.